Okay, so I've started recording. Uh, so welcome everyone. Today we have the workshop 5, and we are going to focus on auto scaling that we could not finish last week, and then some serverless applications, and then some infrastructure as code tools that we can use to automate the infrastructure creation. So last week, when we were building the auto scaling group, we had an issue. Let's go to that and try to fix that. So let me sign in first. Okay, so we were having issues with our private instances in our private subnet. They could not connect to the internet to get to run some bash commands. Actually, what we were missing uh, is right. Our instances could not run these install commands in the private instances because they could not get those repos from the internet. So I suggested a fix there last week to add a route to the private subnets route table to the internet gateway, but that was wrong. Apologies on that. So what you need to do is you need to have a NAT gateway, network address translation gateway created. So then the private instances can use the NAT gateway to go to the internet and get whatever the data from the internet. And also it prevents any instances in the internet creating connections to your private subnet instances. So it does two things. Mainly, it allows internet access to the private instances, and also it provides security to those instances in the private subnet. So what we are going to do, we first need to create a NAT gateway, and this is also sometimes might incur some expense. So you will have to use those AWS credits I gave you to uh, settle your bills. So I go to create NAT gateway and I just give a name. So I give like project NAT1. And then now NAT gateway has to be placed in the public subnet because it needs a public IP also. But then if you want to enable something like high availability, so uh, let's assume your application or one of the AWS availability zones goes down. So in such situation, it is good. The best practice is to have multiple NAT gateways in at least like two availability zones. But due to the because they are expensive, we are not going to bother about the availability, but just do our work with just one NAT gateway. So I'm just selecting only uh, one availability zone here. Uh, And if I want to create another one, I'll have to create another NAT gateway and select a different uh, subnet. So I make it a public because I need to get a public IP for this, and this is mainly for the internet related connections. And also you can have a private NAT gateway in case you want to make connections with your internal VPCs with other VPCs if you want to create a connection, or if you want to create a connection with your data center, you might need a private NAT gateway. So elastic IP allocation means we get a public IP to this NAT gateway. So its purpose is if you are making a call to the internet to get some libraries or repos to download a certain repo, whenever the request leaves to the internet from your network, uh, it should that request should know where the response should come back to. So in such situations, the request will get the NAT gateway's public IP as its source. So whenever it goes to the library and gets those libraries back, it knows I should go to the public IP of the NAT gateway, and then when the request comes there, response comes there, it automatically translates the routing back to the particular private instance. So that is the purpose of allocating an elastic IP here. So you have to click on this allocate elastic IP. So we get a like allocation ID, and then we leave the rest as default and create the NAT gateway. Now we will see, we will get a public IP address for this NAT gateway. So it's still ending. And when it comes up, we can update the route tables of our private subnets to point the internet traffics to this NAT gateway. So then it can download those libraries without any issues. So let's do that. Go to the route tables. The, the project. So these are the private route tables, like route tables of the two private subnets. So I'm going to edit their routes because last time I added the internet, I routed the internet traffic to the internet gateway, which is wrong. So I'm going to go to edit routes and remove this internet gateway target and put here a NAT gateway project map one. This is the one that we created. I'll enter. And similarly for the other, because now our auto scaling group will be adding instances to both these private subnets. So both of them should be able to go to the internet to download those libraries. So I'm going to update the same route in the other route table too. This is also still pointing to the internet gateway. So I'm going to update that. Now, if we try to uh, mm, what we can do, we'll go to the auto scaling events, sort of scaling groups in the EC2 console. This is the one that we created last time. Let's see. Mm, Unhealthy instance and service, right? And let's see, now we connected everything last week, like the load balancer is connecting to the target groups. Everything should be here. Let's see. And so in addition to what we did last week, what the only changes we did was creating the net gateway and updating the route tables. So let's go to the currencies up the target group. Let's see. We have one target already here. Let's see. So what I need to do, I want to do to remove this instance. I want a new instance to come up and see if it downloads it properly. Let's see. I'm going to shut down this instance from the EC2 console and then see if a new instance get attached to this auto scaling group. So I'm going to start this one. Now we should see the scaling should spin up a new instance here. It stopped. It says unhealthy. And the instance is coming up. And let's see. So now we have updated the route tables and everything. The initial user data script that we gave for that instance, this script should run fine. And add new instance. Okay, now it says in service. Let's go to the target group source. The initial previous target is draining and a new one is coming up. Let's see. So now you see after its initial state, it became unhealthy. So this is something I wanted to teach you. So these are the kind of errors you will have to fix if you become a site reliability engineer. Your targets are failing, targets are become unhealthy, and they don't register properly in the target group. So let's see what's the issue we have. Let's go to the load balancer and enter its DNS name on the browser to see if we get anything here. Okay, so the browser, it seems this is the Apache homepage, right? From yeah, the Tomcat homepage. So when you run this initial user data, this HTTPD, and when you start this HTTPD service, this page is visible. But our targets, even though we get a successful page, our targets are not yet registering. So there must be an issue here. So let's do some diving and see. I'm going to show you how you can troubleshoot this. Let's go to the network. network tab here. So, to go to the developer tools in Chrome, you have to go to the shortcut is function and F12 in Mac, maybe control and F12 in Windows. Oh, there is developer. You go to developer tools here. So these menus will appear. So if I go to network here and I refresh this page, I see this. This is the DNS name of this load balancer. This is this web address URL. But you see here, I'm getting a 403 status code. 403 is not recognized as a successful web response. Now, in the load balancer health checks, we mentioned that we are expecting a 200 response code of 200 for the health checks to pass. So because this page is giving a 403 status code, that is why we have a difficulty registering instances as healthy targets. So let's go to the health checks in the target groups and see. So it says success code 200 should return. So what we can do, we are going to, why it is returning this 403 is generally, if you want to return a 200, you should have some index.php or index.html file in this location. If you don't have that file, Tomcat default automatically returns this error test page with a 403. So what we can do, we can update our user data script or the launch configuration to put some index.php into this location, and then it will give a 200 response code, and the target should register properly. So let's do that. What I'm going to do, I'm going to update the launch configuration. So launch template is this one, and I want to modify template and create new version. The only change I want is to update the user data script. Don't want to change anything else. So, okay, enable HTTP everything before I start the server. I'm going to put a file here. A simple HTML file with this text here. And I'm going to place that in text.php. Now, because this file has some permission issues, first of all, I need to I'm going to first create the file here. So it just creates the file, and then I want to append this text to this file. Then before that, I need to update the permissions of this location. Or maybe the file even. Okay. So I update the permissions of this index.php file to allow read, write, and execute permissions for all the people like the root user, the user group, and all the other users. They all can modify this file. So it makes me easy, it makes things easy for me to write this content to this file. So this is the update I want. And so I'm going to create the template version. And so the latest version is 2, default version is 1. So I want to make the default set default version to the latest one. So when the auto scaling group triggers a new instance, it will automatically use the default, the latest version. Version. It is set to use the default version. So I'm good. So what I'm going to do, I'm going to stop this instance that was initially launched. So a new instance will come up with the new launch template. I'm going to start this instance. Let's wait for a new instance to trigger. If you want to drop halfway, that's all right. I'll do this recording and share with you. It's office day and I know you have other commitments. So if you want to drop, feel free to. It's okay. Okay, so instance is stopped and let's see a new one will come up. Yeah, this one is coming up in pending state. Okay, now it is in service. It's running and see if we got a targets registered now. Okay, now you see we got a healthy target. And now if we refresh the load balancer URL, we should see that index page we created. Yeah, we got that index page. And if you look at the network request, now it's returning a 200. So that was the issue we had while the targets were not registering properly. So we have fixed that. Now I can demonstrate you how the auto scaling happens. So to do that, I'm going to connect to my Bastion and then to my web server. And I'm going to increase its CPU utilization to like 50% and then show you how new instances get added to the auto scaling group. So let's this use Bastion test tool. So I told you now because we are going to connect to the Bastion and then to the private instance, we need to have a way to secure the pen file because we cannot save it in the now we can copy it from the from my local machine to the Bastion and then use that, but it is not safe. We usually don't uh, save pen or the pen keys, the SSH keys in instances, in public instances, because Bastion is a public instance. So we use what is called SSH agent. So we add that key to the agent with this command. Uh, so now it is added. Now we can easily SSH. We'll put A here to represent that we are going to use the agent. And then we can use the public IP of the Bastion first. Bastion. This is Project Bastion. Okay. That's okay. I think it should still do. We will you can add the Bastion on also here. Both the pin files are added. Now we should be able to SSH into the Bastion. Okay, now we are in the Bastion. Now we want to use the same agent to SSH into our web server. So this is our web server, and we have to create its so private IP actually. Okay. Okay. Now we are in the private web server. Now if I go to the if I want to show you the file, the index.php that our launch template created, you can see it here. I'm going to list the maybe I need that for the system to the file. So this is where we put the index.php. I want to see the content of it. Okay, so this is all we have in that file. Hello cloud company. Now I'm going to increase the CPU utilization by running this command for 5 minutes, and we should be able to see from the monitoring dashboard how the CPU increases, usage increases. Okay. Now let's look at the instance initial stage. Now initially CPU percentage is somewhere around 18%. Now you should see within 5 minutes it reaches somewhere around 50%, and the auto scaling should bring up a new instance here while the current instance is also running. So let's give that a chance and then have a look at that. So until that happens, let's move on to the slides really quick. So CloudWatch is another service that we use in AWS that is mainly for logging. Now, if you are familiar with Java, you may have used Log4j, and sometimes in if you are troubleshooting a very simple program, you do like print statements in the code itself to troubleshoot issues whether the variables are assigned properly, just to see where their values and all. So similarly, if you are when you are running a very long, very big application, you cannot do print statements. You need to put the logs to a particular destination. So for that, you use the CloudWatch mainly. And today I'll show you one example where we can use a CloudWatch log group. So, and the other purpose is generally these web servers that I was SSHing into, we don't allow developers to go into these instances to see the logs, because if they do something like deleting or changing any configuration of those instances, your application might go down. So because of that, we just transfer the logs from the instance to a particular location like log group in the CloudWatch. So then we give access to the developers to view them. So that is the one purpose of CloudWatch, because the mainly the site reliability engineers or administrators, they have access to the instance OS, or how they can only they can directly access the web servers. And then in addition to CloudWatch, sometimes certain products use tools like New Relic or Splunk for much detailed log classification, log filtering and all. But CloudWatch also does a pretty good job in log filtering and log creation, log comparison, everything. So it's mainly for system monitoring. We use the CloudWatch log groups. So let's have a look. Maybe now should see. So we have instances here. Still not. Hmm. So, let's okay, now you see here our CPU utilization increased to 78 something, 70, like almost 80%. And we should see, okay, now we see two instances added, like one additional instance added to our auto scaling group to handle that additional load. Now after 5 minutes, this load will come down. And yeah, so it's after 300 seconds, it's after 5 minutes, stress failed. So like the stress program exited, and we should see this additional instance removed uh, from the auto scaling group. So let's move on with the slides. So the other thing I wanted to discuss today is the serverless applications, and why we want to like consider serverless, because if you consider server application, fully server architectures, they have certain overheads. Like you have to worry about security, patching, and all those additional things in addition to the business logic that you want to implement. So that is extra burden. So because of that, they AWS, they have, and other cloud providers, they have introduced serverless solutions. So they provide just the like a platform where we don't have access to the OS or the networking or any terminal, but we can just run our application in that architecture and see the application logs. But the behind the scene handling of the OS configuration, maybe network configuration, all those minor details, they are handled by the cloud provider. So that's a very good thing, but sometimes the serverless application, their hourly charges are high, but that is more reasonable compared to the extra burden you will have to carry on if you want to do all those patching and network configurations on your own. And then one other benefit is, now if you run server applications, whether your code, whether there is anything happening in your application or not, you still pay for the idle time. Now, for instance, let's assume you have a some school assessment application where students are taking tests mainly in the spring semester. So if your application is a servered application, it will be running the rest of the year without much use, but you are still paying for that. But if you move to serverless application, you will pay only for what you use during that springtime or whenever a user wants to do some work. But the rest of the time, you don't incur any expense because you are not running any service. So there is a cost benefit also associated with that. And some serverless applications, they provide improved scalability. I'll show you one today, one application like there are some things called serverless functions that you can run, and you can scale them from like one or two to maybe 10,000 uh, executions if you want without much issues. But if you want to scale server applications, there are some limitations. How many or what server sizes available, or whether they are available in the particular region you want likewise. So improved scalability is also another advantage of serverless applications. So in the AWS serverless spectrum, we see several services. So EC2 is like it has most operational burden, but most flexibility now. If your application needs a lot of network configurations or customized network configurations, customized OS configurations, then you will have to stick with EC2. But if your application is using general default OS and networking configuration, you can move to something like Fargate, and you can just run your application and see the logs, and you don't have to worry about configuring other things that are not directly related with your business logic. And another extreme end of serverless technology is called Lambda, where you don't have like any, now in Fargate also you have something similar to an instance, but it is not actually instance, but just a platform. But when it comes to Lambda, you don't even worry about the platform. You just worry about your code only. So you can just run a function whenever you want to, and then uh, get your work done and shut down the environment and everything. So Lambda is like it has the least operational burden, but least flexibility. You cannot do any network configuration, noise configuration, or anything in Lambda. So that is the spectrum, and we are going to do some sample serverless application today. Now, in cloud or in outside the cloud, you always get applications where you allow user to upload a particular image or any document, and then you do some processing, maybe compress the image, or you extract some data from that file, and then you write that to another location, or you do that data, you write those data to a database, and then you move that file from where the user uploaded it to another destination. So likewise, that is a very common application in most of the like systems. So I'm going to run something similar today. So what we are going to do, so in such situations, we really don't need a server application, right? Because you don't need to run a server all 24/7. You just need to run some code when a user uploads a file, and then finish it off. Uh, so you don't need to incur additional expense. You just need to pay only for the processing that you do with that file, and then once it is over, you don't need to incur any expense. So let's see how we can implement something very simple like that without using any servers. We still see two held instances, I think, because you see here, it's still somewhere around 20. And I think in the auto scaling of the thing, we said this, we had to, we didn't put a thing. I don't remember the password. Maybe it should come down in a while. Okay, so let's move to the S3 console and see if we can get that application set up. It's not too difficult. What I'm going to do is I'm going to create a folder, it's a folder, even though we call it a folder, it's a prefix in S3 terms. So you allow user to upload files to this prefix, and then you do with the user uploads, you trigger a Lambda function which does some processing and copying it to another location. So that's a very simple thing, but very heavily used in the systems. So let's see how we can implement it. It's not. I'll share the code and everything for the Lambda function with you when I upload the video. Let's just demo it for now. So I'm going to use this bucket here that I previously created, test2 harsha123. So I have several files here, but so what I'm going to do, I'm first going to create a folder input, do the rest as default, and then I'm going to create another folder output. So what we are going to do when a user uploads a file to the input folder, we trigger a Lambda function and copy that file and move that to output folder. So we have to do now, we'll create the Lambda function also. We go to Lambda console. So I'm going to copy this code that I previously created and create a new Lambda function. So I'll go here and go to create function. So Okay. So I'm going to use some Python Lambda function. So I select the Python latest one, 3.9. Architect, I leave it as this one. Uh, then going to create the function. The code source area. I'm going to paste the function that I got to it previously. So this is the function that I'm going to use to copy, and I click on the deploy button. So the function is now deployed. So these changes I did are now actually in the function execution. So I go to the S3 bucket again. And in this bucket's properties, we have something called event notification. So events means S3 events means whenever somebody uploads a file, when somebody deletes a file, when somebody renames a file, events are triggered. So you can associate that Lambda function with a event notification. So whenever somebody uploads a file, uh, this one you can trigger that Lambda function. So whenever user uploads anything to this prefix, to this input prefix, and if I want to limit suffixes, like if it is only a JPG file, then trigger this function. If it is some doc file, then trigger this function. So I can select all the events that I want this function to be triggered to. So put anything. So I'm just going to consider the put operation now, put events, and yeah, the rest I'm leaving. So the destination, this event's destination is a Lambda function. So you have other options also. And so I'm going to use the new Lambda function I created and save changes. Okay, now the Lambda function is created, S3 event notification is created. Now, one other thing we want to do, we have to give some permissions for the Lambda function, because we are reading that S3 bucket and copying, moving an object from one location to another. We have to give our Lambda function like S3 read write access. So for simplicity, I'm going to allow full S3 permission here for this Lambda function. So I'm just attaching this S3 full access policy to this function's role. Every function has an execution role. So it mainly has permissions like creating log group, log streams, and everything. So you can track the execution of the function through a log group. So if you want to troubleshoot why the function is not working as you wanted, you can go through the log groups and see. So we have attached the permission, and now we can run the function by uploading something to this bucket. Let's go to input location and upload a file. So I'm going to upload these files. .jpg. Okay, upload it, and I can monitor how the function gets triggered in the functions monitor tab. Now you see here, there is no trigger yet. Maybe we can refresh the page to see that S3 event notification gets here as a trigger. So that S3 triggers this function. You can have other triggers also, like event bridge, or some EC2s can also trigger Lambda function. So Here we are using the S3 events to trigger this Lambda function. Okay, so we got the S3 trigger, and see, now we can see the matrix, like similar to the EC2 matrix where we were watching the CPU utilization, memory, and all that. We can see the matrix for the Lambda functions also. So like how many times this function got invoked, and how much memory it used, all those things you can see in the matrix. Still not, yeah, it takes some time to transfer things from the Lambda to the CloudWatch. So let's see if we have anything to compare to it. Yeah, our function has executed properly because we had an empty folder earlier. Now we have our file here in the output folder, but there is some delay in getting those metrics and logs into the CloudWatch. So let's wait for a few more minutes. Yeah, so we see that there is invocation. We see one invocation few minutes before, and then we can see the logs here of the function executed. Logs are still not coming. It will take another 15 minutes for the logs to pass. So that is how you can run a serverless application. And then the next thing I wanted to show today is the infrastructure as code concept. Let me share that first. So infrastructure as code, or IAC. This is another tool that most organizations use currently. Now, people use Git or Bitbucket, all those version control system to get the history of your code base, to mark certain milestones using tags and all. Similarly, to structure or to get versions of your infrastructure and to update them, to track the changes, also we can use this infrastructure as code tool. So there are some ways you can programmatically, the same way that when you write a Java or a Python program, you can use some of these tools to create infrastructure using programming languages. So it supports this continuous integration and continuous development for infrastructure. So you can deploy new instances, you can add new subnets, or you can create new databases using programming languages. Uh, then in infrastructure as code tools, you save the current state of the infrastructure in some storage. You can save that in S3, you can save that in local storage on whatever. And then whenever you want to upgrade your infrastructure with these tools, what it does is it maps the current state that you already have saved with the new changes and suggest you, okay, these are the change. I'm going to delete this instance and bring this new instance up. I'm going to delete this subnet and bring this new subnet up based on your new changes. So you can approve them or you can revert your changes. That is the flexibility that the infrastructure as code tool provides. So some of the tools, popular tools, CloudFormation, that is one of the AWS own services for infrastructure as code. And then Terraform, we sometimes use that with TerraGrant, another wrapper. And then Ansible is also considered as an infrastructure as code tool. So if you know some of these, you have a very high advantage when you go for a job, because these are some of the most sought after skills in the DevOps world now. So I'm going to show you how you can run a Terraform project. So let's go to the folder structure and try to identify. Sure, I will some. Okay. Uh, so in a Terraform project, you usually have some files called Terraform files that ends with TF extension. So let me show you. So so I'm going to use this two. I'm going to use two tools called Terraform and TerraGrant. So what you need to do, okay, so I have this initial project, Terraform TerraGrant project. In that, I have two folders, infrastructure and modules. And in this infrastructure, I have a TerraGrant file. So in the infrastructure, I have this file. It specifies where I'm going to save the states of my infrastructure. So I'm going to save the backend or the state in the S3 in this bucket. So this is a new bucket that will be created. And inside that, we'll have a Terraform project folder, and then the state will be created here in USDist1. So DynamoDB table is like a log table. So when you are working with a particular module in Terraform, other applications cannot use that module. So that's a kind of locking mechanism. So you won't have issues with multiple programs trying to update your infrastructure. Then on the module side, you have the Terraform file. So it's very simple to follow. You first provide the provider, AWS provider, and then here what you do is you try to get the all availability zones in the particular region. And then you create the same way that we created VPC and subnets in the console. You can specify AWS VPC resource and give it a name. So it requires these parameters. So you can specify them as variables, and you can specify those variables here in a separate vars.tf file. Like var.cider means we are pointing to this var.cider. This is the cider for the VPC. And here, so all these parameters you can specify tags you want. Then the subnets, public and private. So here we are going to use two. That is why we put a count here, because we have here two private siders and two public siders. So we are going to create two subnets, two public and two private subnets. So they will be taken here with an index for each private subnet. And that version is where you specify the Terraform version you want. So we specify Terraform version 13 or above here. And that's the main structure for Terraform and TerraGrant file. And in the infrastructure side, you have a network similar to the modules network. You have infrastructure network, and you specify, I want to, for the Terraform source, I want to use the modules folder, network location. And then if you want to customize any of those variables, you can provide them here too in the overrides file. Now you see here, in the VAS file, I have not given a region. So for this region here, I don't specify a default value like this, but I'm specifying it in the overrides. I'm specifying region USDist1 in this override file. So what it does here is, like I say, you can use the overrides file also, and then use this network as the source. So to run Terraform and TerraGrant, you first need to install them. So it's a very simple command. You first need to use do install Terraform. I'm not going to run that because I already have that installed. So you install that and you run do install TerraGrant to install TerraGrant. Uh, So then you can easily run TerraGrant commands, but in the back end, it's actually running a Terraform code, but TerraGrant is like a wrapper. You can customize based on your products, environments, and everything. So I want to show another thing here. That is the now we learned how you can use the console. Console means you create instances, everything by clicking on buttons, menus, everything. And in the Lambda function, we use the what you call the Python SDK for the AWS. So when you call this Bo23 client, Bo23, all these are like Python AWS SDK we are using. So each language has its own SDK. And today we are going to learn how to use the CLI, AWS CLI. So to do that, you have to install, run brew install AWS CLI, and then it's either this or this. So it will just install it for you. And once it is installed, you just need to run a command here. But before that, we have to create uh, some credentials for our user to use the CLI. So what I'm going to do, I'm going to get to my IAM user and create some key and a password. So I go to security credentials. And here I don't have any access keys, so I have to create one first. So I'm going to use command line interface. And I click next. I don't want a description. I say create access key. Okay. Now at this time, if you click on done, you won't be able to get this. So what I'm going to do, I'm going to download this CSV file, or I'm going to move this screen to the other side to copy my access key and secret access key and paste them. Uh, now I can click on done. Now I have copied my access key ID and secret access key. So you see the I have one access key ID. So when I run AWS configure, it usually asks me to uh, set up my access key ID and all those default values. So I don't have an access key ID. So I'm going to copy my access key ID, paste it here. And now it's asking me for the security secret access key. I'm going to paste this here. And then default region I specify as US East 1. And then default output format I put JSON. Okay. Now I'm good to run any AWS command. So so I did the wrong thing here. Yeah, switch from here because I was running it in my web server. So I have to run it here first. Going to so I have a software here, and this is my secret access key, and then here's this one. It's okay. Now I have configured my AWS CLI. Now, if I want to, I can run all AWS commands here. Now, AWS S3 ls means you list all the S3 buckets. So if I type this command, it should give me all the S3 buckets I have. So you see, I have two S3 buckets here. I can view everything like using any AWS CLI command. So, and something I forgot to tell you, if you want to learn Terraform like further, what you need to do is in this time I created this type of resource. So I type here and enter Terraform. So then I can go to that resources documentation page in the Terraform and see what are the parameters it accepts and what are the parameters its arguments it passes when the VPC is created. See here. So you can just provide a side block, or if you want all these additional uh, parameters, you can specify, gives the entire list of arguments that it accepts. So we are providing DNS support, DNS hostname, side block, and tags. Those are the ones that we provide here, as you can see. Lifecycle is also so kind of a tag or a block in this resource. So that is how if you want to create an EC2 instance in private subnet, you can specify that too. Like AWS EC2 will have its own documentation page. You can go here. EC2, EC2 instance. AWS instance, yeah. So this will create you an instance, EC2 instance, wherever you want to. You can specify the instance data, everything. So you can actually, the same thing that we did in the console, you can write using Terraform. And then we were in the middle of setting up we have set up the AWS CLI, and now we can run Terragrant. We go to the infrastructure, the network folder, and then we simply run Terragrant command, Terragrant plan. So when you run Terragrant plan, it shows you what are the new resources that it will create. So it will first ask you to create that S3 bucket for the state, Terraform state bucket. Use allow it, yes, because we still don't have any states created. It first needs to create one. And then now it will show us what are the resources that it is going to create when you run the plan. If you are good with the plan, something forget to delete something. So this is, we won't have this issue. I forgot to delete something in the Dynamo console. I can delete that first time. Then this will be good. Okay. Now we'll run the plan again. Okay. Now, one thing I want to show you, if you want to point to a like a Git repo, you can do that. Now I'm pointing to my local folder here. If you want, you can specify your Git repo too for your infrastructure and specify that one here. So now it says output of the plan. 5 to add, 0 to change, 0 to destroy. So there will be 5 resources that are created. One is the VPC and 2 subnets, public, one subnet, public subnet 1, public subnet 2, that left 0 and 1 indices. Then the 2 private subnets. So altogether 5 resources will be created. If you are good with the plan, you can run apply and it will create this for you. Okay. So it gives the plan output again, and you can just give your confirmation value as yes, and it will create those resources. And we can see in the console how the VPC and subnets are created and how the state files are updated also. So it says creation complete, creation complete. Okay. Now let's go to the console and see how these are created. Let's go to the VPC, see the VPC. Okay. So this seems to be our new. Okay. So Terraform project, this is our new VPC we created. And if you go to subnets, you should see the So maybe here. Yeah. So here you can see the Terraform project. So these are the subnets created from the Terraform project. Okay. And one other thing, the state files, we can have a look. So there should be a new bucket here, Terraform state. So it's just an output of what it created. We can go to step project like and Terraform, but to your state. Bench. So here you can see the entire thing we created. AWS subnet resource. We have the private. So we had two, index 0 and index 1. These are the two private subnets it created. Then these are the public subnets, two public subnet, and this is the VPC created. So all those things are saved. So whenever we want to run a new thing, new update to the infrastructure, it will be run against the state file to see what are the updates that are going to happen, and it will show us, okay, I'm going to change one to change, maybe one to destroy, and then only if we approve, they will be applied. Now, after we are good done with the work, we can actually run Terragrant destroy to destroy the infrastructure also. So I'm going to run that too. And let me show you. After I run the destroy, this file will be just empty, but an empty file, like empty state file, will still cost you in the S3 because it's an object in the S3. So after you destroy the infrastructure, you better delete the S3 bucket as well, along with the DynamoDB Terraform logs uh, table. So you have to delete this one and this S3 bucket both after you destroy. And also please remember to shut down or disable your load balancers once you are done, because they are going to incur you some cost and you will be charged for your credit cards that you have added. So once you are done with the testing and learning, please shut down your EC2s, RDS instances, and remove all your S3 buckets, and remove load balancers, auto scaling, everything. Okay. If your instances are in auto scaling group, whether when you shut down an instance, one will automatically come up. So you better delete the entire auto scaling group before you shut down the instance. So now it says when you run the destroy, it's going to destroy 5 resources. I give yes, and it will remove the entire thing. Okay. Now if I open this file, if I refresh this file itself, its resources are empty. Okay. But I still have to remove the bucket content. So I'm going to go here. It took some time today, but these topics I wanted to cover, and I want to do some microservice scaling activity next time if the time allowed. But I wanted to cover all this because some of these things I could not cover in my workshop one, but this time I covered quite depth, and you can continue on that if you're interested. What's this? First, I have to empty the bucket. Uh, Okay. Now I have permanent, like empty the bucket. Now I think I should be able to delete it. Last the bucket now. So I copy action. Okay. Yeah, that's files. I'm going to, because I shared the my video here, my access case. I'm going to deactivate and delete my access case also. Okay. Yeah, that's all. And hope to see you next week. I'll share the video and the code for that along with the video. Thanks everyone for joining. If you have any questions, feel free to ask, or you can stop for today.
Okay. Thank you, Rashid.
Okay.